Good morning, class. Here's exam 4 review covering chapters 4, 5, and 6.1. Here's section 5.4, indefinite integrals and the net change theorem. 5.5, the substitution rule. All right, so 5.4, indefinite integrals and the net change theorem. What is the net change theorem? The integral of a rate of change is the net change. The integral of a to b f of x dx is the integral of a to b capital F prime of x dx or capital F of b minus f of a. This principle can be applied to all of the rates of change in the natural and social science. Let's go look at one of the examples that we've seen before in essence, the integral of x plus 1 over square root of x dx before we look at the net change theorem. All right. Whether we differentiate or integrate, the very first step is to change the square root of x to x to the power 1/2 and make up two fractions. X over x to the power 1/2. Remember the exponent is 1 here, 1 minus 1/2. Okay, so you make up two fractions. And as I mentioned, this has exponent 1. So that gives you x to the power 1/2 plus x to the power of negative 1/2. And now we are ready to integrate. So this one, 1 over 1/2 plus 1, x to the power of 1/2 plus 1. This one, 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1. And since there's nothing else, we're going to tag along a constant at this step. 1/2 plus 1, 3/2. Negative 1/2 plus 1, 1/2. Now, division by 3/2 means multiplication by its reciprocal. This becomes 2/3, this becomes 2. So 2 x to the power of 3/2 over 3 plus 2 x to the power of 1/2 plus a constant. And you're done. If you want to put it in the same format as a square root, you could change this to square root of root, and you can change this to square root of x cubed or square root of x cubed. Either way is fine. Just the algebraic step if anybody is interested. A bacterial colony increases at the rate of R of t equals 2.2 e to the power of 0.4 t bacteria per hour. If the initial population is 800, find the population after 12 hours. Well, this is the rate. So we let capital R of t represent the actual population. So capital R of t represents the population and capital R prime of t equals lowercase r of t represents the growth rate, where R of 0, the initial population, is 800. This is the synopsis of what is given. So the accumulated change or the amount of increase in population after 12 hours is the integral of 0 to 12 R of t dt. That's the accumulated change or net change there. And so you are going to replace the lowercase r of t with 2.2 e to the power of 0.4 t. Because it's an exponential, we are integrating, we are going to divide by 0.4. So 1 over k e to the power of kx. So this becomes 2.2 divided by 0.4 e to the power of 0.4 t. And we want to evaluate it from 0 to 12. Now, this is the same as 22 over 4. Or simply put, 5.5. Now you're going to plug in 12, you're going to plug in 0, and of course, this is 1 because it's e to the power of 0, but and this is 0.48. Nevertheless, you have to put it into a calculator. And of course, this represents the number of bacteria. We are going to round it accordingly. And of course, we add the initial population. So this becomes 663. Initially, we had 800. You're going to add, and we get 1,463. Now, and we're done. But I want to look at a second method. A second method is to find the equation for capital R of t in general, which means you are going to look at this, but not paying attention to the limits. And we already have the answer, which is 5.5 e to the power of 0.4t, but this one adds a constant because it's not a definite integral. It's an indefinite integral. Now we know R of 0 is 800. So 5.5 e to the power of 0 plus is 800. Of course, e to the power of 0 is 1. 5.5 plus what number is 800? 794.5. Replace it. And that is R of t at any time t. After 12 hours, we want R over 12, and that will give us exactly the same answer. As far as which one is easier, you decide, but the bottom line is you really have to know both methods. And I think the advantage of this one is if they ask you to find the population in several different times, 12 hours, 10 hours, 15 hours, then this is easier rather than redoing this process. All right, we want to evaluate the following integrals. Sine of 2x over sine x. Well, reminding you that sine of double angle is 2 sine x cosine x. So we are dealing with 2 cosine x dx, and the derivative is negative, but the integral is positive sine, so therefore it's 2 sine x plus a constant. Dx over x, notice that this means 1 over x times dx, so the answer is a natural log. And because the limits are positive, we don't have to put an absolute value, okay? Otherwise, we must. So it's ln of the top minus ln of the bottom. You can simplify it into ln of 6/3, which is ln of 2. And that is a precise answer. You're going to keep it as a precise answer always. Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? Rounded to 1 decimal. We are going to look at this question similar to what we just did with the application in example 34, and that is first understanding the concept. So this is the growth rate. So that's in essence the derivative. So if that is the case, we let L of x represent the actual length of a fish at any age x. Then the growth rate, that means L prime of x or dl dx is this, with the initial value starts the life with a length of 1 centimeter, with L of 0 being 1 centimeter. So this, in essence, is explaining what the question is asking us in a symbolic format. So the amount of increase, again, it follows the net change theorem. So the amount of increase in the length after the first 4 years would be the integral of a to b f of x dx, so the integral of 0 to 4, 29 e to the power minus x dx. So this is the amount of increase. So obviously, the derivative of e to the power minus x is itself. You divide by -1 or you multiply by -1, right? That's the format. And we get -29 e to the power minus x. We plug in 4, we plug in 0, and we can take the -29 out. In any event, this is 1, but this one is 1 over e to the power 4. You have to put it into a calculator. This becomes negative times negative is positive, 28.4688. And the initial value L of 0 was 1. We are going to add 1, and then we go with 1 decimal. We add 1 and 1 decimal. That means stop at 4. Next to it is 6, 29.5 centimeters. So what we did, we found the amount of increase and we added to the initial value. Instead, we can find the actual function. In other words, let's integrate this, and we already have the answer plus a constant where the initial value is 1. So we are going to replace the x with 0. L of x is 1 to find the value of constant. So L of 0 is minus 29 e to the power minus 0 plus c equals 1. E to the power minus 0, e to the power of 0 is 1. So you're looking at negative 29 plus what number is 1? C must be 30. And you replace it. And now this is L of x in general. So what do we want after 4 years? Replace the x with 4. And you get the same answer, and I put it with the same decimals first before rounding. Now the advantage again is that if you want it after 5 years, 7 years, 10 years, all you have to do, plug it in here. So it makes it a tad easier if you have several parts. Otherwise, it makes no difference. A particle moves along a line so that its velocity at time t is v of t equals t squared minus t minus 6. And it's measured in meters per second. Find the displacement of the particle during the time period of 1 to 4. So basically, we want S of 4 minus S of 1. And it's important to understand as we go from T1 to T2, okay, and we cover this distance. So this is the T, and this is the V, the velocity, and the area is what we cover as, we have two things. The displacement, it is simply the integral of V of t dt. And of course, A1 is positive, A3 is positive, A2 is negative. But the distance, you have to add all of them. So in essence, you put it in an absolute value sense. So what we are doing here is S of 4 minus S of 1 in this case, which is simply the basic integration of V of t dt. So let's replace the V with t squared minus t minus 6. And this gives us 1/3 t cubed minus 1/2 t squared minus 6t. And I'm going to leave it for you to evaluate. Plug in 4, plug in 1, and we end up with -9/2. I want to make a point, and that is the result could be negative, could be positive, because it's a displacement in a positive direction or in the negative direction. However, distance is a different story, and it's always positive. So we don't want to mix them up because it's the absolute value. Now, this part, so the particle moved 4.5 or -9/2 or 4.5 meters towards the left. See, because we are mentioning in a negative direction, and then we don't write minus 4.5. Second part, find the distance traveled during this time, and we take the absolute value of that. So the distance would be the absolute value of A to B, the integral of A to B absolute value of V of t dt, which is the absolute value of V of t dt from 1 to 4. Now, to evaluate this, you have to know where this function is positive, where this function is negative, and you are going to go with the sign graph. But before you do that, you have to factor. And factoring this, you want t, and then you want two numbers. The product is -6, the sum is -1. So it's +2 and -3. So you factor this and you use a sign graph. This is 0 at -2 and at +3. Now, although the time is really from 0, but you can evaluate it just the way it is because we are interested in the sign. And bear in mind, this has degree 2, and we have two different answers. Therefore, if you find one of them is good enough, the rest of them will alternate. So you are going to use a TP or test points. Obviously, in between, the easiest would be 0. This would be, for example, -3, and this would be, let's say, +4. All you have to do is just do the 0, and then they alternate. So if I put the 0 here, obviously it's easier. I see -6, so it becomes negative. They will alternate. And bear in mind that we really are going from 0 to infinity because it's time. But nevertheless, over here is negative, over here is positive. So where it's positive, you use the function itself, t² - t - 6. When it's negative, the idea of the absolute value to come up with the positive one, you negate that. So for this part, which is from 1 to 3, by the way. So this means go from 1 to 4, from 1 to 4, in between is 3. So you're going to go from 1 to 3 and then 3 to 4. From 1 to 3, you choose the negative part. So you negate that because it's negative. And from 3 to 4, because it's positive, you don't have to. Bear in mind, I did the sign graph from negative to positive infinity. In essence, is really from 0. But just wanted to remind you of that. So this one would be the integral of -t² plus t plus 6 from 1 to 3, and this one would be just itself. Now, this one -1/3 t cubed plus 1/2 t² plus 60. This one is what we just had there. This is from 1 to 3. This is from 3 to 4, and I'm going to erase my work. You have to plug in 3, plug in 1, come up with the answer. Same thing, 4 and 3, come up with the answer. I'm going to leave it for you to do that. Becomes 61/6, precisely, roughly 10.17 meters. The distance is always positive. What we have covered. Displacement is a different story. Okay, difference between the value of a definite integral and total area. That's really the concept of total area is the distance, and the value of definite integral would be the displacement, for example, what we just did. Find the area between the x-axis and the curve y equals cosine x. In other words, this is what we want. Okay. And it's important to understand that if we want to go with the integral, this is positive and it works, but this is negative. So the integral represents the difference between the two areas. So this is what you have to do, the absolute value. So this is positive, everybody. This is negative. So if you don't have the absolute value, you find the difference of areas. Obviously, this is larger, as you can see. You can work it out, of course, we will show you. Then the result, if you don't have an absolute value, will be negative. So we are going to evaluate this when it's positive from 0 to pi/2, and when it's negative from pi/2 to 3 pi/2. So we're going to negate that. In other words, the integral of 0 to power 2 cosine x dx. And then from power 2 to 3 power 2, we're going to negate that minus cosine x dx. So this part, okay. As you know, the derivative of cosine is negative sign, but the integral is positive sign. So this is sine x from 0 to power 2. And this is, take the negative out, in essence makes it easier, then you get the same thing, minus sine x, but this time from power 2 to 3 power 2. So again, I want to make sure we understand. This is positive. This one, take the negative out, take this negative out, and this is the same thing. Now, so that means sine of power 2 minus 0 minus parentheses sine of 3 power 2 minus sine of power 2. So as you know, sine of power 2 is 1, sine of 0 is 0. Sine of 3 power 2 is negative 1 minus 1. So one more time, this is 1 minus 0 minus, this is negative 1, this is minus 1. Obviously, we have 1 minus negative 2, which adds up to 3, okay? Which adds up to 3, and that's important to understand. Now, value of the definite integral, if we don't pay attention to the absolute value, this becomes sine from 0 to 3 power 2. That means sine of 3 power 2 minus sine of 0. You all know sine of 3 power 2 is negative 1, and this is 0. So the answer is negative 1. In other words, let me just, so this is minus 1 minus 0. So it's very straightforward, everybody. All right. So again, a quick recap. We want to make sure we understand the difference between the two. And that is, in the first case, we have to take the absolute value because we want the area, absolute value. If they're all positive, then it makes no difference. If it's not, it does make a difference. If you want the value of definite integral is the difference of areas, okay? 5.5, the substitution rule. Integration by substitution is the reverse process of the chain rule in differentiation. For example, capital F of g of x, the composite function, if we differentiate, we get capital F prime of g of x times g prime of x by the chain rule. And if lowercase f represents the derivative of uppercase f, so capital F prime will be replaced with lowercase f. Now we let u represent g of x, and du dx is g prime of x, which makes du g prime of x dx. So notice the integral of f of g of x, we're going to put f of u, and g prime of x, okay? Now we are going to put du because it's g prime of x dx. We need the dx, otherwise the integration makes no sense. And this is capital F of u, or capital F of g of x, plus c. So over any interval for which u equals g of x is continuously differentiable and f is continuous, and the range of this function, the following relationship holds. The integral of f of g of x, g prime of x dx, where g of x is u and g prime of x times dx, it's important, times dx is du, the same as the integral of f of u du, and it's capital of f of u plus c, or capital of f of g of x plus c. This is known as the u substitution, which means you must always define u and du to be able to move on. So let's start with a very simple example. We want the integral of 2x, parentheses x squared plus 5 to the power of 30. And that's the reason you use the substitution. Notice you can't raise this to the power of 30. It takes forever. And so here's the tip. Look for a function u equals g of x anywhere in the integrand and then find its derivative du or g prime of x multiplied by dx. So whenever you have uh, polynomial functions, this is one of them, this is another one. The more complicated one normally is the choice of u. And this is more complicated than that. U is x squared plus 5. Notice if you differentiate, du dx becomes 2x, and therefore du is 2x dx. Now, you don't have to write this. This you have to write, but I just want to make sure that you understand how we arrive at it. Now, to make sure this is understood, we're going to move things around. I'm going to put the 2x next to dx. This is u, this is du, so you can say u to the power of 30 du, and that uses the power rule, everybody, which is 1 over 31, u to the power of 31, plus a constant, and now u, if you replace it with x squared plus 5, you're done. And if you have any doubts, differentiate the final result, you should get this part, of course, without the dx, everybody. So, a quick recap. When you have polynomial functions, the more complicated one without the exponent is normally the choice of u. Then you find du. And then in order to make it easy to understand, you move things around. In this case, I moved the 2x next to dx so we can clearly see the du versus u to the power of 30 and du. This way we can easily come up with the answer. 5x to the power of 4, e to the power of x to the power of 5. Now, what happens when we are dealing with exponentials? If we have exponentials, and a polynomial, the exponent of the exponential almost always is a choice of u. So in this case, the exponent is x to the power of 5. If I differentiate, I get 5x to the power of 4, and therefore du is 5x to the power of 4 dx. So again, I'm going to start moving things around. So in other words, I'm going to put the 5x to the power of 4 next to dx. And clearly, this is e to the power of u, and this is du. So now we know the answer. E to the power of u, the answer is itself, and a constant. And now I'm going to replace the u with x to the power of 5. And the final answer is e to the power of x to the power of 5 plus c. And as always, if you differentiate the final result, you will get this without the dx. So 5x to the power of 4, e to the power of x to the power. Now, again, we have a similar situation. We have a polynomial and we have an exponential. The choice of u is always, almost always, the exponent, which is x to the power of 5 minus 2. Okay. Now notice, if I differentiate this, again, I get 5x to the power of 4, and therefore du is the same thing, 5x to the power of 4 dx. Just like this, I'm going to move things around. I'm going to put x to the power of 4 next to dx. So here's what becomes interesting. When we go back to this one, we had the du. When we are looking at this one, we don't have the du. Number 5 is missing. So in many texts, including yours, they actually solve for dx and they put it here. I give you an easier way. When a number, a coefficient, a multiplier is missing, just a number, you can put the number in here. How do you undo it? It's reciprocal. So throw in 5 and 1/5. Now, remember, a number can be in or outside the integral sign. Please understand the product of these two numbers must be 1. This is the fastest and easiest way to do it. So now you're dealing with 1/5, the integral of e to the power of u, and this entire thing is du. So you do have the du now. Therefore, now the answer is just like that. This gives you the same answer here. So, but don't forget the 1/5. So 1/5 e to the power of u plus a constant. And of course, u is replaced by x to the power of 5 minus 2. As always, if you have doubts, differentiate the final result. It must give you this without the dx. And it does. Well, uh, we don't need any substitution. We are going back to something fairly basic. We want to integrate 5 plus 2 cosine theta d theta. When I look at 5, I have to pay attention to the fact that my independent variable is theta. So 5 gives me 5 theta. Cosine, the derivative is negative, but the integral is positive sine. Therefore, positive 2 sine theta and a constant. So that's pretty straightforward, everybody. All right. The integral of 4x plus 1 over 2x squared plus x minus 3. So how do we deal with a fractional format? In this case, more specifically, we are dealing with a rational function. Okay. The very first thing is any fraction, more specifically rational function, can I factor, can I simplify and put it in lowest term? If I can, I must. So notice this is 2, so it's 2x and x. This is negative 3 is 3 and 1, one of them negative. I'm assuming you can factor it into 2x plus 3 times x minus. Now, even if you can factor, however, the top doesn't have one of those factors, it doesn't simplify. So there is nothing you can do. You just continue. How do you continue? If you have a fractional format, not necessarily a rational function, and you can simplify, the denominator is a choice of u. So u is 2x squared plus x minus 3. What is the derivative? 4x plus 1. What is du? 4x plus 1 times dx. Now, again, to make sure we understand what's happening, I'm going to put the dx next to 4x plus 1. Therefore, we are looking at du over u. And that is the natural log. So natural log of absolute value of u plus a constant. Replace the u with 2x squared plus x minus 3, and that's the final answer. By the way, you keep the absolute value unless you are positive this expression is positive. Since we don't know, we keep it. Of course, we can say that it can be both positive and negative. That's why we keep it in an absolute. Now, please understand these two are similar. In other words, I kept the same denominator, but I've changed the numerator slightly. And why have I done that? Because I want you to notice the numerator, I can take the 4 out, and the denominator has x minus 1, and I must simplify. And that's the difference between the two. One more time. This one, although I could factor the denominator, couldn't simplify, so I just moved on. In this case, I could factor the numerator, so I can't move on. First, I have to simplify. After I simplify, then there's nothing I can do. Then I choose the, and by the way, remember 4, that means 4 dx. Dx belongs to the numerator, never, ever belongs to the denominator. I want you to know that. So there is nothing else we can do to simplify it further. We choose the denominator as u. So if u is 2x plus 3, du dx is 2, which makes du 2 dx. And notice the numerator is 4 dx, which is 2 times 2 dx. And the reason I write it this way, because I want the numerator to be du only. So 2 times 2 dx is the same thing. I just took the 2 out. I can even take this one out, but I don't want to. And the reason is because the numerator is du and the denominator is u. So in essence, this part is just like that. And so natural log 2, ln of absolute value of u plus a constant, and u is replaced with 2x plus 3. The final answer, 2 ln of absolute value of 2x plus 3 plus c. And if you differentiate the final result, okay, you will get this one without the dx. Now, here's an interesting example, because I want you to be exposed to variations of fractional formats, or more specifically, this is rational format. So instead of, look at this one. Instead of this one, I'm going to use its reciprocal. Take a look. This is the reciprocal of that, everybody. 2x squared plus x minus 3 is at top. 4x minus 4 is at the bottom. So you do the factoring, and it simplifies to this one, but this time 2x plus 3 at top, 4 at the bottom, dx. So again, please understand, the reciprocal of this is the same as the reciprocal of that. My point being, we must use substitution in parts A and B. In this case, we don't need to. Rather, we make up two fractions. This is half of x, and this one is 3/4. And none of them require substitution. Please understand, the integral of is half of x squared, integral of x. So with 1/2 becomes 1/4 x squared plus 3/4 x, and a constant. I'm assuming nobody has any problem with integrating half of x, which becomes 1/4 of x squared. So a quick recap. All of them are rational functions. This can't be simplified. The denominator is the choice of u. This can be factored and this simplified. Do not start with the given. Must simplify it first. And then again, u and du. The reciprocal of this doesn't require the substitution method. So distinguish between the two. All right, again, we have, I'm going to call it a fractional format, because this is a rational function, but this is not, okay? But the methodology is similar in that you try to simplify. When you cannot, the choice of u is the denominator, just like a rational function. So if you differentiate this, this gives you 0, this gives you e to the power of 2t, therefore du must be e to the power of t dt. So I'm going to put this next to e to the power of t. Remember, this belongs to the numerator. And in essence, you're dealing with du over u. So the integral of du over u is familiar. It's the natural log of u and a constant. We are going to replace the u. Natural log of 5 plus e to the power of t plus a constant, and we are done. As always, differentiate the final result. You get this one, but not the dt, without the dt. Now, what about this one? The first thing first, can I simplify the denominator? Well, we can't. Why not? Let me remind you of something from algebra. The quadratic formula indicates ax squared plus bx plus c equal to 0. X is minus b plus minus a squared of b squared minus 4ac over 2a. And the discriminant is b squared minus 4ac. Everybody remembers that. Now, the discriminant gives us a lot of information, everybody. If it's positive, we have two distinct real solutions. If it's 0, one real solution, rational. If it's negative, no real solutions, two complex solutions. Furthermore, if b squared minus 4ac is a perfect square number, then this can be factored, this quadratic function can be factored. Otherwise, it can't. So let's just look at this. I hope you recognize a equals 1, b equals 2, c equals negative 1. So b squared minus 4ac is 2 squared minus 4 times 1 times negative 1. 2 squared is 4 plus 4 is 8. Is this a perfect square? No, it cannot be factored. Therefore, u is the denominator, x squared plus 2x minus 1. So I wanted to remind you of something from algebra. Let's differentiate. If you differentiate, you get 2x plus 2, which makes, that's the u dx, which makes the u dx. So this is 2x plus 2, or 2 times x plus 1. So du is 2 times x plus 1 dx. So I'm going to put the dx next to x plus 1 so it becomes clear. Everything is in order except number 2 is missing. And as I've mentioned before, in many texts, they solve for dx. You can go with that route, but I'm going to show you again, and I'm going to repeat. This is much easier. Because number 2 is missing, I can put it here. How do I undo it? With its reciprocal 1/2. Please understand, you can't just put number 2. You have to put number 1. How do you put number 1? Any number you choose, also, you have to put its reciprocal because their product is 1. So now, the numerator is the u, the denominator is u, and the 1/2 outside remains. So this is a natural log, so 1/2, ln of absolute value of u plus a constant, and u is replaced by x squared plus 2x minus 1, and that's the final answer. Now, again, to make sure we are comfortable with the concept, I want to look at the reciprocal of this one. So what happens when you look at the reciprocal of this one? Well, you make up two fractions. This is 5 e to the power minus t, and this is 1, meaning we don't need substitution. This one, we know the antiderivative is minus 5 e to the power minus t because you have to multiply or divide by -1, plus 1 because this is t, and a constant. In other words, no substitution is needed. And that's the idea behind understanding a fractional format that requires substitution versus the one that doesn't. Integrate square root of 3x plus 7, the integral of square root of 3x plus 7 dx. This is somewhat different and interesting. So first and foremost, when you come across this, it's the same as 3x plus 7 to the power 1/2, and you let u be 3x plus 7. If you differentiate this, you get 3, and therefore du is 3 dx. Now, I'm going to solve for dx the methodology that most texts use, just so you're exposed to that. I don't care for that too much. But if I solve for dx, I get dx equals du over 3. This is the method that, and this is, by the way, simple enough that really makes not much of a difference. So this integral is the square root of u, and instead of dx, we have du over 3. Or 1/3, because this is 1/3, right? And because we want to get it ready for the integration in the form of a power rule, we're going to change this to u to the power 1/2 du. Okay? Now, however, I want to show you when I don't do that, I stick with this. So this one, I notice that du is 3 dx, but I don't have it. So I put the 3 here and 1/3 outside. If I put the 3 here and 1/3 outside, please understand this is the same as this one. I believe this method is a tad easier, especially as this gets more complicated. But if you are okay with solving for dx, that's your choice in any event. And this, we are going to integrate. 1/3 remains. This one, we are going to go 1 over n plus 1, 1 over 1/2 plus 1, u to the power 1/2 plus 1, and a constant. Now, of course, 1/2 plus 1 is 3/2, and its reciprocal is 2/3. The product of 1/3 and 2/3, and u to the power of 3/2 and a constant. This is 2 over 9. U is replaced by 3x plus 7. You get 2 over 9, 3x plus 7, the power of 3/2 plus a constant. You can put it in the same format if you want. In other words, you can write it as 2 over 9. Okay. Square root of 3x plus 7 cubed, and a constant. If you like to work on it, that it's your choice. If f of x is 4 e to the power of -0.2x minus sine x, we want to differentiate and want to integrate. I want to do both of them because sometimes students mix up the two. And to do so, let's find f prime of x. It's 4 times the same thing times -0.2 minus sine gives you cosine. This would be -0.8 e to the power minus 0.2x. This is minus cosine x. So again, 4 remains the same thing, and then times -0.2 because you're differentiating. Now, if I want to integrate, I have to put a dx next to it. So I'm going to integrate the same thing times dx. And so this one, when you remember, when you differentiate, you multiply by negative 0.2. When you integrate, you divide by negative 0.2. Okay. And minus sign. So this is 4 over negative 0.2 e to the power of negative 0.2x. And minus sign becomes plus cosine and a constant. Now this is 40 over minus 2, right? So negative 20 e to the power minus 0.2x plus cosine x plus a constant. Now let's also add an initial value problem. If the initial value f of 0 is 20, that means you have the pair 0, 20, replace the x with 0 and capital F of x with 20. So f of 0, let's see what happens. Obviously, this is 1. Cosine of 0 is also 1. So we have minus 20 plus 1. So we have minus 19 plus c equals 20. So c must be 39. And so we replace it here. And here's the idea, everybody. I want to make sure we understand what we are dealing with here. And this is a general solution because we have a constant, we have a family of functions. And this is a particular solution. In other words, this represents infinitely many different functions. And because of one pair, we found the C. This represents only one of those functions.